Just before I start, feel free to ask questions at any point during the talk. Just shout out, and then if you're too shy to do that, send it to the link above and I can pull up the questions on the computer. That's all anonymous. So yeah, thank you for having me today. My name's Hugh Halford-Thompson. I'm co-founder and CTO of BTL Group. We've been involved in the blockchain space for about 5 years now. We set up a Bitcoin brokerage 4.5 years ago. After exiting from that, we started BTL Group last summer. We raised some money and got listed on the Toronto Stock Exchange. And what do? We do workshops and educational workshops around the blockchain. We do consulting, and we build proof of concepts and implement products in both the payments and financial space, as well as in the wider data sharing space, which has a lot of applications in healthcare. I'm going to start off with a little introduction to show what really is a blockchain, because there's often some confusion there. Don't worry, I won't go too technical. And I'll show you some of the applications that are possible today in the healthcare industry. So blockchains really enable, for the first time, it's a tool that didn't exist before. They enable the transfer of ownership or the sharing of data without having a central party, without having the trust that is required for that system in a traditional sense. What does this mean? You can have blockchains really remove the need for trust between different market participants, between different companies looking to share data between each other. And you had, we had the internet before, which is really the internet of information. Where everything is built out from sharing information. You still have those central points of trust that really make the internet work. So blockchains mean that you can remove the need for that trust in a lot of situations, and it can really restructure the way things work. Just with a quick history of where blockchains came from. Bitcoin was the first blockchain that really got out there and hit the press. It's a combination of several technologies, including cryptography, peer-to-peer networks, brought together academics from game theory and fintech. And really it put together a really clever incentive program on top of this distributed network and this distributed database, and then added Bitcoin to it, which is a tradable asset. Bitcoin was the beginning. For those of you who haven't really seen it, it's kind of like the internet money. You can use it, it's not quite pounds, it's not bank backed, but you can use it to buy and sell things. As Bitcoin grew, it encouraged a whole wave of innovation in the cryptography space and fintech space. The first change came with Ethereum. There's a few others that have grown out of that. And they really invented smart contracts, which is a way to do trusted computation as well as sharing data. You can actually have a trustless source of computation where no single party is running the server. So whenever you've got a process and you've got a central party running that server, they have effectively a monopoly over that process. Everybody has to trust them. Now you can have it in a way that everybody can trust them, effectively everybody is running it equally. So you don't need to trust that central point. So what is a blockchain? Quite literally, and this is the most technical slide I've got, so don't worry too much. A blockchain is literally a chain of blocks. You've got each block pointing back to the previous block. And what this means is that if you change any of the previous blocks, it breaks the chain. This is important because it means that you can't go back and change historical data. Anything that goes into the system, if you go back and change it, it makes it basically really, really obvious to everybody else that you're trying to go back and change something. Within each block, you can have a set of transactions or a set of data, which has been appended to the ledger, and each block is appended to the blockchain at set time intervals. So as each block is issued, it gets sent around the peer-to-peer network. Every server in the network holds a copy of that, and it gets added to the chain, making a blockchain. So this is a quick example of how it might look being set up. I'm going to walk around here. On the left here, you've got effectively, this could be either a single organization or a group of organizations. And you've got to imagine they don't want to have a central party between them, and they've effectively all got equal access and equal control over the data in this system. They might also want to open up the system so that other people can have read-only access, maybe third parties, other companies, regulators, depending on the application. So before going into the, so in a moment I'll go into the specific use cases, but before that I want to take a little look at some of the features that blockchains enable. So the first one that I've already mentioned is data that is entered into the blockchain is immutable. That means once it's in, no single party can delete it. A blockchain effectively acts as a witness to an event and is incapable of lying about what it's witnessed. This gives you a perfect auditable record. There's public blockchains out there. There's different ways of setting it up. You can have a private network between a group of organizations, and then effectively each organization is a witness to that event. Or you can have some of the public blockchain networks like Bitcoin and Ethereum, which effectively give you 6,000 anonymous witnesses around the world. So it's impossible to go back and change that data once it's in. Participants in a blockchain network can trade and share data without having to trust each other and without having to trust that central party. So again, that's new in terms of the structure of how markets can be set up and how data sharing can be set up. And then smart contracts, I could talk about all day, but they enable a huge amount of reliability and redundancy. And again, no central party is controlling it. So going into a bit more detail, when data's entered into a blockchain, it's submitted by one of the nodes on the network. That could be one of the companies involved in that process. They share this data around the network so that everybody's got a copy. The next block that's created will have that data inside the block, and then the block, and then every server in the network then verifies: is this data valid? Do I accept this as a standard format? If they do accept it, they then reach a consensus, which is effectively a democratic vote to say this data is true and verifiable. Let's put it in the block. And you can think of the blockchain in effect as a database where everybody's agreeing to what goes into that database. This gives you a nice immutable record of events. So the use cases around blockchain, the use cases from auditing are numerous across many industries. Basically, any situation where you can gain an advantage by changing historical data can benefit from a blockchain. I've included a non-healthcare use case just as an example, so you can see how widely this can be applied. But Secure Play is effectively an auditing platform for fancy sports companies, so they're gambling companies. It gives full transparency by storing sensitive game data like the odds or jackpot amounts. And there's a lot of companies who have been caught changing the odds after somebody's won a jackpot, for example. Obviously, it's not allowed. So coming towards some of the healthcare use cases, provenance of goods. This is in healthcare. It's also across many other markets. But when you're tracking provenance of items, whether it's artwork, diamonds, food, aircraft components, or if you're tracking drugs through the supply chain and trying to make sure that the drugs you're taking are not counterfeit, so they're not just placebos on the black market, or they're not something a whole lot worse, you've really got to track every person who's touched it, every person who's owned it through that supply chain. Now, by tracking items on a blockchain, you can remove a large proportion of the counterfeits in the market. For pharmaceutical drugs, you need to trace it back to the original labs where they're made. Currently, without a blockchain, if you do this, you're relying on a central system, which means you need a central trusted party. Normally that means regulation, it means overhead and cost, but it also means a risk of attack because that central party could obviously change the data for depending what the incentives are. So that's normally why regulation exists in these spaces, is to stop those sorts of things from happening. So if you put the data on a blockchain, no single party can change that data. Once the data is stored, once the ownership is stored, and you follow that drug through the supply chain, there's no way for anyone to go back and delete that historical data. Question?
I don't understand that statement, no single party can change the data, because clearly if you input something, it goes in and everybody agrees that it's changed, and then all of the things in the distributed ledger change, do they not?
So when you put, think of it as an append-only system. So you can add stuff to it, and if you put if you put a certain bit of data in and then you want to change that, you can then put another line in saying, that was wrong, I'm changing it to this. But there's a record that happened.
If I say, oh, I've sold this bag of pills to somebody else, I type that in, I may or may not be trustworthy, and then it appears everywhere in the distributed ledger, and it might actually be false, but it's given the credence of truth because it's in other places, so you get sort of great crowd of computers saying, oh yes, that did happen. And
so you've got two, I guess.
Am I wrong about that?
So if you look at items that you want to track, there's two types I'm going to break it down to. One is where you've got a fingerprint, a perfect fingerprint of the physical item. So in drugs, there's there are some where you can link specifically to the drug itself and check that this is through testing that drug and check this is the exact chemical formula, etc. In other items, you've got things where you've got multiples of the same thing, or where you can't check whether one's real, or where you can't match the physical item to the digital identity. So in cases where you can match it, firstly you can always test and see is this the valid one that was being transferred through. In cases where you can't match it, I say we can remove most of it. What you can't do is remove somebody. If you've got a small black market drug trade, you're getting a few for yourself and then selling off to a few people. Effectively, the number that you buy give you the same. When you buy the drug, you also get the ownership tokens. Now you could replace the drugs you brought with some fake ones, sell those, and then keep the real ones for yourself, or sell them off on a black market. What you can't do is sell 10. You can't just buy one and then sell 1,000 of the same one because you've only got one ownership token. So that really knocks down the wider counterfeit market. Cool. So yeah, removing the need for the central party really changes the way the market's set up, and can also, it gets rid of a lot of the friction that's required to set up these central parties as well. The final example on here is around access control. So if you want to control access to sensitive records, be that patient records or whether it's secure areas, it's susceptible to the same attack as other centralized systems if you've got a central log of what happened. And in most situations, there's a database admin somewhere. Sorry, can everyone hear me? In most situations, there's a database admin somewhere who has control, and they can go back and delete what happened and effectively change the historical record of what happened. In a blockchain, you have a very simple mechanism of sharing that data around different participants or hashing it into the public blockchain, which means that if anyone wants to go back and change it, in a private blockchain, you've got to persuade everybody, which might include regulators, etc., to change it with you. So you're not going to be able to commit fraud there. If you hash it to a public blockchain, you've got a huge number of witnesses around the world, and it's going to be very, very difficult, impossible to persuade them to change the record. It gives you an immutable copy of the access logs in effect. So on a slightly different example, the old way to connect siloed data between different areas of an organization is generally around putting a great big central server in the middle of it. So you've got all your siloed data, or it could be different companies who appoint a central server, a central exchange, or a central data store, and you feed all the data in. Everybody can read from that central source of truth. This works when you can find somebody to trust in the middle. It does create monopolies. It creates a lot of power for that person who's appointed in the middle. So within an organization, this works. When you've got multiple organizations, if you've got multiple NHS trusts or multiple different organizations in any industry, there's often commercial incentives that mean that this is impossible. Effectively, you're asking everybody to give up control to a particular person, so not everyone always agrees on that. So what tends to happen is, without that central party, you can have records falling out of sync between different organizations, and this causes reconciliation issues. You've got different copies of data in different areas. Trying to pull all that together and work out what actually happened can be very expensive. In other cases, it just doesn't happen at all. And I've actually, this is in the financial world, actually this is in the travel world, it's a group of travel agencies and corporate companies paying for their travel fees, where I've witnessed where effectively they're trying to negotiate a bill at the end of the month where neither party really knows how much they owe each other. They've gone through, they've each got a separate accounting system, so they've got siloed data on either side. Both know that their system's a little bit wrong. They don't really agree with each other, and they're putting a finger in the air and trying to work out, do I owe you 200 grand or is it 250? I can't quite remember. I've done that personally when I've lent somebody 50 quid. Do they owe me 100? Do they owe me 30? The following week you forget, and on a bigger scale that becomes a big issue. So you'll see a little bit of crossover from the auditing use case, but by putting a blockchain in between these organizations, you can remove, you can connect them all together and remove the central party in effect, or the need for that central party. So you've got a decentralized data store where everybody's got a same copy of the data. You remove those silos, guarantee data synchronization, take out that central repository, take out the need to set up that trust in the first place. This means that you can share the data between the organizations without changing the very structure of the business relationships they've got between each other. Everybody's got a copy of all the data and they've got equal power, or they can have varying power depending how they want to set it up over that system, which is equivalent to what they had before implementing it. So again, the use cases are varied across all sorts of industries, but they apply to any organization or group of organizations looking to share the same data between each other. If they're all trying to keep a record, a ledger in sync between each other. So from removing the need for reconciliation between companies in the supply chain to really ensuring budgets are accounted for. Sorry?
So how do you overcome the limitation I understand that you have with Bitcoin of the number of transactions per second is strictly limited? You're talking about systems with a lot of transactions.
Yep. So can I jump back to that one? There's a few different ways of doing that. So yeah, there's just to go through the use cases quickly first. If you're so I've gone through the reconciliation example where you're trying to keep sets of accounts between each other. One of the use cases I've been working on recently, and this is at sort of concept stage still, but there's a group of NHS trusts, doctors and pharmacies, and I think there's an insurance company who's looking at it as well, who are trying to share patient data between each other. And effectively they need a central party, they need a central source of truth where they've all got a copy of the same data. But because of the commercial relationships they've got at the moment, nobody wants to give up that control. So again, you can put in a blockchain and give them all equal control to what they have now, and they can all access that single source of truth and guarantee that everything's in sync.
Can I just ask a question? Sorry. So in the NHS,
Yep.
there are two issues, kind of maintenance of the golden record for the patient and accuracy. But in theory, not always in practice, the centre of the patient record is the patient.
Yep.
And key to that is the relationship and granting of access, which is why you retain central records. It's in theory, so the patient can tell you who they have a relationship with and their record or not. So how is that applicable?
So that is solvable in this system, and it's also, there's a live example of that in Estonia, where they've done a distributed ledger system. It predates blockchain, but effectively with patient record data, if I get, the problem is I can share it with specific doctors, specific hospitals, an insurance company, whatever I want to share it with as a patient. But the day I get hit by a bus, I might be unconscious, so I can't then grant somebody else access. So you need a way for the effectively the institution or the people coming on board to be able to access that data. But if you have a log that is patient central, where the patient can always see everybody who's accessed it, then that means that anyone who accessed it and shouldn't, in Estonia, that's I don't know if that's finable or imprisonable, but it's a very serious offence. Then similar stuff could be done here. Yeah, as long as you got that perfect record, you can keep track. Yeah, in effect. So the patient wouldn't necessarily run. So one of the use cases we deployed in the gambling world is where you've got the gambling companies are the consumers don't trust them for, they've been changing the odds, they've been doing different things. So what the more honest amongst them want to prove that they can't go back and change it. So what they've done is given, there's two things. One is read-only access to consumers, so you can download a full copy of that data. Most patients won't be doing that, but the technically savvy, some of them might keep a copy. There's some other third parties who do it. And what that means is you've got however many people run that system and opt to run that system are effectively witnesses to the event in case anybody accesses a record. The other side of that is you can put a hash of that data, which is effectively a fingerprint of the full document in the public blockchain, which has a huge number of witnesses around the world as well. So that gives you an extra layer of security. You can hash it into other blockchains. So yeah, the use cases come down to effectively what people need, what entrepreneurs want to build, and what businesses are demanding from it. When the internet came about, I didn't imagine quite such a connected world, and it changed the way we share information. Blockchains will change the way that we trade and the way we trust and the way that we share data. What that means is it's going to change the way we can set up trusted networks, trusted relationships, and business relationships between companies. So the question you asked earlier around scalability. So the Bitcoin blockchain is effectively hard-coded to only accept 7 transactions a second. Although people are working on changing that, I don't know if it will ever happen, and I wouldn't guarantee it. If you have a private blockchain, so we use Ethereum as a base technology, and you can have a private blockchain set up within that. As a standard install, you can hit 50 on high-end hardware, maybe 150 or slightly more transactions a second. When you're looking to do higher volume stuff, there's 2 ways of doing it depending on there's a few ways depending on what sort of data you're putting in there. So for anything that's transactable, so trails of ownership through a supply chain or trading of an asset in a financial market, you can set up what's commonly known as payment channels, where effectively you do you do one transaction on the blockchain, and then you can do 1 million transactions off the blockchain without having to touch it. That's just a standard database scalability question, but without losing that trustless advantage that you get from a blockchain. So at any point, the parties in this system can effectively go back to the blockchain and claim the parts that are theirs. That works for financial tokens mostly, or whether that's shares or anything that's tradable. I think this is going weird. It is. Should I just speak loud? Yeah. Cool. Can everyone hear me at the back? Perfect. If you're looking to audit huge data sets, effectively you can make, if you want to look into the tech, it's making a Merkle tree effectively. But what you do is you take a fingerprint of either the whole set of data or parts of that data, and you can post that fingerprint to a blockchain. What this means is that because not everybody's got a copy of that data, if you go and change that data, everybody knows that you've changed it. What they don't know is what you changed it from. So you get different advantages depending how you lay it out. One of the big advantages from that is you're not sharing any data with the other participants. It's just at any point you can pull up the original and say, this definitely matches with what I said last year.
So basically what you're saying, it's not that you've got every piece of information distributed. It's just the stuff that you need to verify, or as you say, like hashing it so it's fingerprintable.
Yep.
So, right. So in terms of healthcare records. I mean, I can't. There's so much stuff, scan stuff, this stuff. I can't imagine that being distributed in a chain.
So the first thing in healthcare is, and the first thing in any organisation actually, is come out with a standard digital format which would work with normal database systems and other systems. Unfortunately, in the UK in healthcare, there's a lot of issues with digitisation of paper forms. That's one that blockchain's not necessarily going to help with. But when you're when you're moving beyond that, you can get advantages from any of the data that you need, where you need to share either the full data or where you need to share the proofs. That's where you get the advantage. Nobody's going to be sharing video libraries. Nobody's going to be sharing that sort of stuff. What you can do if you want to, if you've got CCTV footage of something, you've got evidence for something that happened that you want to keep, you make a hash of that video, keep the original somewhere, and then at any point you can prove that 2 years ago this video was made. I haven't tampered with it since then.
I want to ask, bar Estonia, which is an outlier here, when do you think there'll be diffusion of blockchain technology within the healthcare sector?
So I think, yeah, Estonia is a long way ahead in this, in that they actually predate Bitcoin and my involvement in the blockchain. But I think the UK risk falling behind slightly because it's very difficult to get consensus among all the NHS trusts, among all the various different parties, some of which I know, some of which are just a long list. In other countries, or in private healthcare systems, it's much quicker to implement stuff. So really, it's a case of how quickly they're already implementing technology. But
Do you think it's like 5 years' time, 10 years' time?
That's a hard one. So I think for patient records or something like that, that's debated in politics. So it depends when the Prime Minister wants to push it ahead and that sort of stuff. There's a lot of wider questions attached to that. In terms of smaller use cases, whether it's tracking prescriptions, going from doctor through patient and through pharmacy, you can ensure that prescriptions haven't been faked. That's something that you could do between one doctor, one pharmacy, maybe bring in a few patients as a start, and then grow that network out. There's different smaller use cases or more confined use cases that will be implemented earlier. So I think the first live use cases will be in. I hate putting a number of years on this, but certainly in the next 2-3 years we'll see something. The wider use cases will be where everybody really sees the effect is further down the line. So 5-10 years is more reasonable on that.
The obsession in healthcare is with maintaining confidentiality, an obsession that has gone mad.
Yep.
How does blockchain answer that?
Effectively, in a very similar way to what you've got already. So blockchains are built on encryption technology and on cryptography. It's using the same public-private key encryption as you use at your bank, as you use at the Pentagon, and as you use or should use in healthcare and every other industry. At the base of it, if you're encrypting, if you're sharing data, you've got to make sure you're sharing the right stuff. And you're not leaking privacy. It's one of the things that I actually think the harder questions there are probably going to be solved by the banks, who are throwing a massive ton of money at that problem at the moment, and that can be reapplied in healthcare and other sectors. In terms of keeping privacy, you can publish either the hash, the fingerprint of the data, which means you're sharing the proof that it happened, but not sharing the original data. There's no way. That's a one-way function, so there's no way of getting any information out of that, and that's been proven through mathematics for longer than I've been around. In terms of where you need to share the actual data, you can do it through encryption keys. So you can have encrypted data on the blockchain where certain people have access, and then where if anybody else needs access, you can keep a perfect record of that.
But then you have the problem of the number of transactions. You're actually keeping the data.
So there's again, the scalability I could do a whole presentation on. There's from payment channels to private networks to hashing the data. There's also different areas you can do side chains. You can effectively split a blockchain into multiple pieces and start linking those together in different ways. Some of that is live now. A lot of that is research at the moment. Again, the banks are looking at it. Everyone in the blockchain space is looking at that. And there's solutions that exist for specific types of problems and are solved to the point where everything's scalable to standard database scale. There's solutions that are on paper, and that there's some stuff around zero knowledge proof and ring tokens and another one I forget the name of that's been published recently. If that can be implemented in the way it sounds like it's moving in theory, then we can solve a lot of those privacy questions.
Sorry, just one question back to application. Yeah, the NHS probably is the prime market for this because it's kind of nascent in terms of the way technologies and science. But the obvious market is the US, and the obvious target is probably HIPAA. So do you know? Is HIPAA?
HIPAA, yep.
So do you know any examples of where blockchain technologies are being used to support auditing?
So where it's being used currently, it's all the ones I know of are proof of concept stage, looking to roll out later this year in effect. Philips have made a big move in the space, both in healthcare and in Internet of Things, and they've set up a lab doing different tests. We've been in discussions with private healthcare companies in Canada, not in the US yet. There's another one. I should have pulled up a list of recent news, but yeah, there's a few that have started investing in the space and are doing various proof of concepts. In terms of auditing, the big fear that everybody has is that if you put this data out there even on a public blockchain, you're not actually leaking data, but people think because you're putting something out there in public, it must be leaking something. So a lot of that's around education and getting people to understand how this actually works. Not that many people, unfortunately, understand cryptography.
If I wanted to find out a lot about this very quickly, is there a source that you'd recommend to read?
I'll give you my card. There's if you're looking it up online, I would say avoid looking at Bitcoin and avoid looking at if you want for the wider use cases. Bitcoin, let's say there's a lot of people who distract the conversation with the anti-bank, anti-government sort of rhetoric. If you look at a lot of the blockchain use cases, start by searching blockchain in healthcare. There's a lot of YouTube videos and there's some podcasts that are going out. There's several events in London most weeks talking about the technology.
You run your own, don't you?
Sorry?
You run your own.
Yes, so we run blockchain workshops and educational events. We're going to be doing one in I think start of July. We haven't announced the date yet, which is going to be more public for open attendance. And then we do them with companies who bring us in. So we've done events where we go in and teach either the innovation team or the product team and show them how it can work in their specific industry with their use cases.